Hey everyone, my name is Grant Romundt. I'm the CEO and co-founders of OceanBuilders, and I wanted to give you an overview of what we're working on here. We're down here in Panama, and we are building a floating home technology. It's actually a very unique technology that we've developed. It's based on the same exact principle as an oil rig, where you have a deep spar, like the tube that goes into the water, that's filled with air, so it creates a lot of buoyancy. And then at the bottom of that, you have a very heavy weight or ballast. So that makes it very stable. So it's kind of like a bottle of wine, when you empty the bottle of wine, put the cork in it, and then you can throw it in the water, and it will just float there for, you know, a long time. It won't stop floating. So we're using the same kind of structure, same kind of design, and we're putting a house up on top of it. So with all that buoyancy from the empty tube, it actually pushes the house up over the water. So the house itself is going to be about 2.5 meters above the water level. So by doing this, it gets the house up above the waves, so you're not subject to moving around a lot in the waves. So it makes the house much more stable than a normal boat. And really the goal of this whole thing is to give you an experience of living that is similar to what you would have on land, but to now be able to do it on the ocean. So this technology is actually opening up the oceans to being someplace where you can actually live and live quite nicely. But when you normally live on a boat, usually you have a lot of restrictions. Like you only have so much energy, you only have so much water, you only have so much drinking water, as well as you only have so much space for dirty water, like gray water from the sinks in the kitchen or the bathroom, shower water, and then also black water from the toilet. So we're trying, 10 years ago or so, the technology to do this didn't really exist. There's various parts available in different stages of development, but they weren't quite ready for the market. And there's a lot of things that we're missing. And people have been talking about building floating cities and floating homes for a very, very long time, for decades, but no one's really been able to do it yet. So this technology is designed to bring all these different components together so we can actually create a living experience on the ocean that is just fantastic. So this is what we call a sea pod, because it kind of looks like a pod. It's kind of rounded and has that, aerodynamic pod kind of design, and it floats up above the water, about 2.5 meters above the water. So it's a very nice experience. I'll show you some of the images here that we have. This shows the kitchen, and you have a balcony. Here's how it lights up in the evening. The balcony is at the front here, and at the back we have the living room at the bottom, and then the bedroom at the top. And the interesting thing about this design is that it can be used both on water as well as on land. And when it's put on land, it's kind of like a modern treehouse, like a futuristic kind of treehouse. So it would be like this. And the nice thing about this on land is that normally when you build a house on land, you cut down a lot of trees or nature and replace it with concrete and pavement. And in this case, we only have a footprint of 1.6 meters in diameter. So it's actually very small, and we can actually coexist with nature very, very nicely. So that is a concept we really like, because now you don't have to clear cut nature to have a home on land. So we started building a manufacturing plant just before COVID started, and it was finished in September of 2020. And since that time, we have been hard at work building the first prototype, production prototype. We've built a floating prototype in the past, proof of concept, just to test the engineering principles. And now we are actually getting ready to launch the actual production, close to production ready prototype. So this is our location we're at right now. This was before we actually put the manufacturing plant up. The office is right over here. I'm not sure if you can see that in the video. But I'm going to take you to walk around the plant on a little tour a little bit later, so we can play that if we have time on this presentation. So the 3D printer we bought is 20 feet long by 16 feet wide and 8 feet tall. So this thing is just absolutely massive. And unfortunately, we wanted to be able to print whole sections of the house with this, but the technology just isn't ready for this, for what we want to use it for anyway. So we've been developing over the last year a way of using this printer, the bed for the printer, and using it for making a modification on the extruder so it actually can print in foam. So we're trying to do a lot of really cool, innovative things. It's not always easy, doesn't always turn out, but we're trying to innovate and create all the technologies that are going to be needed to create the vision that we're trying to make. This is what the original prototype looked like. This was the engineering prototype, so it wasn't pretty at all. It was not attractive. This was not ready to be sold. This was just to test the principle itself, and you can see here this one's about almost 3 meters off the water, and this diameter here was about 2 meters for this spar, and that worked quite nicely. And this next image actually shows you what it looked like underneath the water. So this was maybe 5 meters under the surface of the water. This was me scuba diving around the spar. And what was really interesting was that there's so many fish. Before this was put in the water, this was about 13 miles from shore. And people think that the water is just filled with life and there's tons of fish and there's tons of coral. But once you get away from shore by, just outside of the coastal area, there's not a lot of life in the ocean. It's more like a desert. And so this area, before we put the spar in the water, before we put the sea pod in the water, it was more like a desert than anything. And this was 2 months later, and there's thousands and thousands of fish. This is a video, so see if you can play it here. There's just thousands and thousands of fish everywhere you looked. It was just stunning how big of an impact this made on the environment. By just having this on for a couple of months, this became a habitat for life. So we really think it's possible to make a home that not only just like on land when you cut down trees and forest and nature and destroy nature, but I think when you build a house on the water the way we're doing it, it can actually become a habitat for life and increase the amount of life on the ocean. So that's something we're really excited about. This is a location where we will be putting these sea pods, and this is an island right behind the homes. It's a very protected area, so there's not a lot of big waves, so it makes it the ideal location for us to have a home. This is kind of another view of the model, and we have a little lounge over here off to the side. And then we have, this is the entrance of the sea pod. So we'll have a door and then a spiral staircase on the inside. And then there's also a door here, you can see, that actually goes to the underwater section if you want to crawl underneath. This is the living room. We want to have growing walls on the sides of the house. The living room view, the kitchen, patio doors, so the kitchen patio doors can open all the way. Master bedroom, have a very nice view from the master bedroom. Huge panoramic windows. The bathroom. We have a climbing wall. We had a couple of 3D printing contests to come up with different designs for different components in the house. These are some of the climbing grips we came up with for the shower. And here we've 3D printed them out and making a master mold. And we also did contest for designing a bathroom sink. And this is actually the mold for the windows. The windows are like massive, so quite a bit of engineering is involved in making these. So this is the mold for the windows. One of the really interesting technologies we're using on the SeaPod is electrocoagulation. Normally on a boat, you have to have freshwater tanks and gray water tanks, and then you have to have your gray water and black water tanks emptied once in a while. And if you've ever stayed on a boat for any period of time, you notice that you have to really conserve water, because you may only have, say, 50 gallons of water to last you a week for 2 or 3 people. Whereas when you're on land, you go through 50 gallons in a day for one person. And actually the average is more like 80 gallons per day per person. So that goes pretty fast if you're on land, and on water you have to really make that stretch. So with this process of electrocoagulation, we're able to clean the water, the gray water that goes down your kitchen sink or goes down your bathroom sink, even with soaps and oils and other things, and just dirt, or if you're, say, in the shower and you're washing your skin and just all this stuff that goes down the drain, it goes through these metal plates, and there's an electric current that goes through it that causes everything in the water to coagulate. And when it coagulates, it clumps up together and it becomes very easy to filter out. Whereas before, it's really hard to filter oils, it's really hard to filter soaps and other things out of the water. So this process is very unique, and we have a company that's scaling this down to be the size that's practical to use on a floating home. So it's very exciting. This hasn't been done before to this scale, so it's really cool to be able to bring this technology out. And we really want to have a house that is able to be powered by itself, to grow a fair amount of its own food, and to be able to clean its own water. So this technology allows us to recycle 100% of the water. We'll see how it works out, but that's the plan, and so far that's what they're able to do in a large industrial plant. And the interesting thing is that we can even recycle black water from a toilet. So normally black water from a toilet is something you have to have collected and take it away. So we're going to have a couple processes. We're going to have a process where we use like a metal grill that catches all the solids, and then the solids are incinerated, and then the liquids pass through and go through this electrocoagulation process, and then it recycles it so it's reusable. It actually brings it to a state where you can actually drink it, but we're not going to do that. We're not going to put it into the drinking water. We're going to have a closed loop system, so all the water coming from the toilet is going to be going through this process and then being cleaned and then being sent back to the toilet. So it's going to have a closed loop system for the toilet. And then once in a while, you're going to have to top up the water once in a while with some fresh water from somewhere else in the house. So we're going to have incinerator toilets. So there's actually going to be just dust left over from the solid to come out of the toilet. So there's a lot of technologies we're developing, and part of the reason we're excited about DEF CON is that there's so many people that are really passionate about hacking electronics and all kinds of different things, and we really want to hack living on the ocean and find a way to make it practical to live on the ocean. And so we have so many different projects we want to develop and innovate and bring all these different technologies together and put them into one home and have a system where you can live on the ocean and have this incredible, amazing lifestyle. So another one of the projects we're developing is a solar thermal system. So we're going to be collecting the sun's energy in solar electric as well as solar thermal. Solar thermal heats water, and then we can use that hot water to use in the showers and use in the sinks. And so it's very cool process, and that process itself is about 97% efficient in collecting the sun's energy and converting it to heat. So that's very efficient compared to solar, which is only about 17% for commercial systems. We're also going to have embedded charging surfaces throughout the house. We'll have NFC control to unlock advanced functionality of the Sea Pods, so you'll be able to open the doors and maybe even have two-factor authentication on the doors, so you can swipe your finger ring, and maybe also use AI to do facial recognition on the front door. You can also swipe your ring in front of the shower, and then it recognizes that it's you, and then it turns the shower on to your preferred temperature. So there's a lot of innovation, a lot of technology. We have a rotary hydroponic system we're developing, and there's some of these that are available off the shelf as well. We have a contest this year at DEF CON to create a salty sensor, and this would be basically packing in as many sensors as we can into a floating buoy that would be positioned in different locations, so we can start collecting weather data, water conditions, wave heights, wave lengths, see how far of a distance it is from the top of one wave to the top of another wave, and then also see how the wave height is. So there's a lot of really interesting things we can collect from data from these sensors, and we have a contest to see who can make the least expensive and most practical floating sensor array. And then we have over 100 projects, open source projects, posted on our website, on the wiki of our website, and we're really interested in having people contribute and collaborate to hack the sea and come up with new technologies, new innovations to make living on the sea an amazing experience. So this is just a collage of some of the technologies that are projects we want to work on or have some development and progress already happening. So we'd love to have you involved in the project and collaborate, and I guess now we'll open the session up to questions and answers. Okay, I am live. I think my camera is on and my mic is on. So if anyone has any questions, we can jump into them now, or we can do a live tour of the factory if that video can be queued up and go to play if no one has any questions right now. Otherwise, we'll come back with questions after the live tour of the factory. Hey everyone, I wanted to give you a tour of our factory. We are here in Panama, and you can see out the window we have this huge project under development, and I'm going to show you all the different parts of it. Before we go down, I'll show you an interesting thing here. We just received this. This is a sonar, piece of sonar equipment, and it is designed to to map the underwater seafloor, because we want to go exploring and look for new locations where we will put our smart floating homes. So we have these huge 4 speakers here. These are the sonar speakers, so it sends a ping out on each of the speakers and then measures the time for the sound to come back, and then maps the entire seafloor. So that's kind of a new toy we just got, but I'll walk around the factory now and give you a little tour. These what the home will look like on the inside, and then this is the view on the outside. So I'll go and show you all the different parts and components. Right now we are in the last stages of putting our prototype together. That's our office that we were just in. We have a research and development area in here. We also actually have a team around the world that's working on a lot of research and development projects there. In here, part of it's a meeting room, and then the other part is we have a space for toilet research and shower research. Living on the water, one of the big limitations is how much water you have. So on a boat, you normally go through maybe, say, 50 gallons in a couple of weeks, whereas on land, you may go through that in a couple of hours or days. So we need to find ways to really use our water efficiently. So we have a system where we're going to be recycling the shower water, the gray water, the black water from the toilets, and incinerating all the waste. So we're actually going to have showers and toilets upstairs in that room I showed you. And then in this building here, we have a space in the open for doing the actual recycling of the water. The actual technology is using a process called electrocoagulation, as well as using ozonation of all the materials, and filters and some other processes. And it looks like we have the demo models probably coming in about 3 to 4 weeks. This is our tool room right here. We have a lot of all the tools we need for the factory. So yeah, we'll be getting the water recycling technology here in 3 or 4 weeks. And that is supposed to recycle about 100% of the water, 100% of the gray water, and 100% of the black water. So basically everything coming out of the toilet will be going through this process and being able to recycle. We're not going to recycle the toilet water back into the drinking water and the shower water and the sink and all that. We are going to recycle it back into the toilet. So we'll have a closed loop system that we may only have to add a few gallons a day, and no more than that to the whole system to keep it running. And most of that water will be that we're creating new is going to be desalinated, and that will be just for drinking water. And we may top up the system from that a little bit. These are the living structures. This one here is in the final stages of having the molds pulled off. So it's kind of a 3-step process. We make the entire structure, so it's like the positive image, and that's our plug. That's what we call a plug. And now we have these. This is actually the plug underneath here, the white piece. These red parts. This is the plug that's being made to go over. Sorry, it's the mold that's being made over top of the plug. So it's kind of like the negative image, and we will use these molds to mass produce the actual sea pods themselves. So it's a very long, painstaking process to make them, and these things are not small, they're huge, as you can see. So there's 12 pieces on the top, and they're kind of like pizza pie shaped, and then there's going to be, this is the top half, and then we have the bottom half in the back there. And that's probably about 6 weeks from being finished. I'll show you in this area here. This is the bedroom. So the bed of the master bedroom goes right in this area. And the window goes from there all the way over to here. So it's a really massive panoramic window that you have in your bedroom. This centerpiece here is where the shower will go. So it's a 1.6 meter diameter shower. It's huge. And the bathroom beside it, the toilet, sink, and then a door going down and walking down into the kitchen, which is at the front of this section, and then the front the kitchen walks out into a patio. Walk around the back here. So here we have This is the center spar that goes through the entire house. So the bottom of the living structure connects to the bottom here, and then the top of the house connects all the way to the top there. So you can see how big it is. It's quite tall. I think that's 7.2 meters tall, and is 1.6 meters wide. It's quite large. There will be a spiral staircase on the inside to climb up from the water level to the top. And underneath this black tarp, we have a rolling machine, and this is how we roll our steel in the factory, which I'm going to show you right now. Which is the steel makes the floating structure that goes under the house, and that is right here. So it's a pretty huge structure. This white platform here is the dock, so that's where you pull your boat up to. And then about 60 centimeters or 2 feet below that is where the water line will be. So it's right here. And everything below that level will be underwater. So all this is going to be underwater and filled with air, and that's what's creating all the buoyancy. Quite a bit of structure that's under the water, so that gives us a lot of flotation. And that's what gives us the ability to have the house propped up so far above the water, because we have all this buoyancy under the water. And there's no, like, you may look at the pictures and think the house is actually connected to the ground in maybe a steel spar or cylinder that goes right into the ground. In our case, it doesn't actually do that. It is free floating, or you can have it anchored, keep it in place so it doesn't move around so much. The outer spars, these sections here would be called outer spars. They're filled partially with concrete, and that one's actually going to be filled with, we're going to have a jacuzzi at the top. So you'll be able to have a really cool little spot to have a jacuzzi. And there will be a rope walkway from the outer spar to the center, right there. And then here we are building a walkway to walk from the center all the way out to the outer spar on this side. And there's going to be a platform up there where you'll have a little lounge area, and then above that lounge area will be an area to have solar panels, which will power the home. So that's a bit of a walkthrough on the project. There's more I can show you, but that's a pretty good overview. I'll show you one more thing actually. We have these big sheets of steel here, and these are, it goes through that machine I showed you on the inside that was covered in the black tarp. We put these sheets through and we roll them until we get the exact shape that we want for these tubes here. We call these our outer spars, these are our outriggers, and then in the center we have the center spar. So that's the factory tour. Hope you like it. Let me know if you have any questions. All right, so there you have it. That was the pre-recorded talk, as well as the live, pre-recorded live walkthrough at the factory. I'm here at the factory right now. It's a Saturday, so the factory is not open on weekends, but I'm here, and we have a little bit of progress since the video was made. We've just moved the platform a little bit further out. We're getting ready to put it in the water. Hopefully in a couple of weeks, we're getting a walkway, not a walkway, but a runway. We have to grade all the land and on the way from here to the water, which is about 200 to 300 meters from here. We're just at a marina. So I will be happy to take anyone's questions if they have questions, or I can just talk for a while and give you a little more details. Also, if you guys are interested, we have a salty sensor contest running. What we're trying to do here at DEF CON this year is to organize everyone into groups that want to participate in building a competing on the contest. And basically, we're trying to promote anything that has to do with living on the ocean and living better on the ocean than we're currently doing. Mostly when you want to live on the ocean now, you live in a floating, like a boat, just a regular boat. And boats have, pretty cramped spaces. You have low ceilings, so you're always bending and trying to duck and not hit your head on things. You have a lot of water limitations and power limitations. So we're trying to make a home on the water that is floating, that is has all the amenities that you're used to having when you live on land. So that's quite a big challenge. So we're trying to overcome some of those challenges with technological breakthroughs, research and development, and we have a contest that we're helping to sponsor this year at DEF CON. So we want to have a basically this contest is to have a sensor buoy, and the sensor buoy can have numerous different sensor devices on it. The more the merrier. But we're trying to have something that's less expensive than what's available off the shelf, because usually what's available off the shelf is a very expensive commercial solution. And we're trying to have something that is inexpensive and something that can be deployed more on a large scale and be affordable to be able to get that out there. So we would like to use the sensor array, or the salty sensor array. We'd like to have it to place in different locations in the water around where the homes that we would like to put in the water, around those areas, so we can start collecting data, all kinds of data. It can be data from wave heights, so it would measure the lowest point of when a wave goes through, as well as the highest point, and then give that distance, and then we can calculate the wave height from that. So you'll have a high point and a low point, and then the middle point. Then you'll know the wave height is from the middle point to the high point. Then we also want to be able to measure the wave length, which is the distance from the top of one wave to the next wave. So when the maximum height of the wave is reached, then the water will go down, and then it'll go back up slowly. So we want to be able to measure the time between one wave height to the next wave height, and then ideally measure the length between the waves. We want to be able to measure the temperature at the water level, and then below water level and above the water, so just above the water line. So we could have multiple temperature sensors for air as well as the water. We can also take sensor readings for pH, for electroconductivity, oxygen content, dissolved oxygen. I think it's called dissolved oxygen. Turbidity is another sensor we're interested in collecting. The area that we're in is right by the water, and by the water's edge. There's a marina about 1 kilometer away. And when it rains, the water goes from being pretty clear to being very muddy, because all the water runs from the towns nearby, runs out the little rivers, empties out into the little bay that we have here, and then the water gets really muddy. And the muddier the water is, the worse it is for the sea life that's in the water. Like there used to be a lot of coral in the area, and the coral has really been decimated in the last 7 years. So we're interested in doing whatever we can to try to improve the environment of the marine area that we're in, of the marine ecosystem that we're living in. So first part of that is to be able to measure the environment. So we'll be using the sensors either attached to our homes that we're building, or by remote buoys that are salty sensor buoys that are in areas around the area. We could have them between our house and the land where the
the river kind of empties out into the bay. But we can also put them a little bit further out and collect weather data for the marine environment further out, where we might want to put the sea pods in the future. But also not just further out to in the ocean, but there's a lot of beautiful areas that no one lives near, that are these really beautiful protected coves nearby here. There's a couple areas around the corner here, are maybe just a few miles from here, that there's not very good access by roads or any other access, but they're really beautiful, gorgeous areas. The water's, beautiful blue, crystal clear blue hue. Not in all areas, but there's some of those really magical spots. So we'd like to put some sensors around and take some measurements. Also, it helps us to establish a baseline for what the conditions are like. And that's really important to us because, say, once we put a floating house there, we want to be able to have scientific data showing that before we put these homes there, there was X number of mass of fish, because we can track, if we have underwater cameras, we could track how many fish are going by in a day by that area. We can maybe track, if we have multiple cameras, we could track, we could triangulate with 3 cameras. We could triangulate the position of the fish, as well as we could estimate the size fairly accurately. And then we can collect actual data day by day, month by month, year by year. And then we'll have data going back, for as long as we've had sensors there. And then once we put a sea pod there, or a floating home there, then we can measure the impact of our homes on the marine environment. We'll be able to say, okay, before we put the homes in the water, there was X number of fish, or X number of, mass of, biomass in that area. And then after a month, it changed by this much. And after 6 months or 3 months or a year or 2 years, it changed by X number amount. We can put all that on a graph and have real data. And I think that would be really, really cool for us to be able to do, and to be able to prove that you can actually build a house that can not only be good for the environment, but actually help to restore the environment and create a habitat for life. And I think that's something we have a really good shot at doing, is creating a home that is eco-restorative and regenerates the ocean. So that's something we're really excited about, but we can't really get there without having good data. So that's why we wanted to start this year with doing a salty sensor. So we're really interested in having people participate and helping us to get to that goal. And this project is being done as an open source project. We're doing a lot of things open source because we want to hack the sea. Ultimately, we're just a bunch of people that want to make living on the ocean viable. And I think it's something that's really exciting, actually. It's like the final frontier on planet Earth is the oceans. And I think if we do this right, we could make living on the ocean an amazing paradise. I lived in a floating house in Toronto for 3.5 years, and it was a really amazing experience. I loved waking up in the mornings and being able to go for a paddle, watch the sunrise, and it was really, really beautiful experience being able to do that. I had many friends come over and visit, and when they came, we'd usually go for a paddle, or we'd sit on the back deck, and I could sit on the back deck and just watch the water float by for hours and hours and hours. It was just a really, really beautiful experience, a really nice way of living. Instead of watching the grass grow from your backyard, you have it's actually really entertaining watching the water and its infinite variety of changes of waves and sparkles and fish coming by and jumping out of the water, and it's quite entertaining and very, very calming and relaxing. And it's when I was living there, I always thought that it would be so great that if more people could live like this, if more people could experience living on the water. And it was a little bit frustrating because when I was living in Toronto in that place, we had. I just have a live question coming through here. Legal. So there's a question coming in on the system here. But what if any legal or permitting obstacles exist in building permanent offshore housing? So okay, I'll answer that in a second. So we there's a law. There's actually only 22 of these homes in Eastern Canada, and all of Eastern Canada, because they were built and then they were moved to a marina just outside of Toronto, 30 minutes from downtown Toronto by car, or about 30 minutes by boat as well. And the government actually banned making any more because they couldn't tax them as homes. So and they actually look like homes. They look like a full-size, normal-looking home, but they were floating. They're basically a home put on top of a concrete slab with foam underneath, which was the buoyant force, so it kept it floating. So it was an amazing way of living, and I always thought this would be so great if other people could experience this, but it really sucked that the government wouldn't let anyone build more because they couldn't tax them. So that seemed like a real shame. So when I saw this project, I just got really excited because I thought this would be an opportunity to give people a chance to experience living on the water. So that relates to this question that StrikePod asks about if there's any legal permitting obstacles for building permanent structures offshore. So right now, the original prototype that we built in 13 miles off the coast of Thailand was our original prototype, and that worked really well for proving the engineering principles that we wanted to have. But as you asked, there's the local authorities weren't all on board with having us there, so it turned into this huge event. Let's call it that. It's actually, we have a book being written about it right now. The book was supposed to be finished last month, but it's not going to be done probably for, I don't know, maybe in another month or so, hopefully soon. But basically, the Thai Navy decided to attack our station, our floating house, and that turned into the largest manhunt in Thai history. And with their you can find us on, if you Google OceanBuilders Thailand on YouTube, you'll probably come up with a lot of videos that tells some of our backstory. I think we have one of the most amazing, interesting, fascinating backstories. So yes, there are some issues with permitting, and basically the homes that we're building now, we're building them in concert or in collaboration with the government of Panama. So we're communicating with them. We're telling them exactly what we're doing, and we're building them. Basically, they're going to be flagged as a boat. So they're just like any other boat for flagging purposes, but even though it looks totally different. So we're going through the process right now. We're just getting ready to submit a bunch of paperwork to the Panama Marine Authority, or AMP as it's called in the acronym. So we're getting our flag for Panama. In Panama, it's being flagged as a houseboat. So we'll have a Panamanian flag saying we're a houseboat classification for a vessel. And that allows us to be anywhere in Panamanian waters. And then we're also negotiating with different countries to get a maritime flag for different countries. But once you have one flag from one country, you can actually use it in different countries and different jurisdictions. So we're pursuing that. It's actually the SeaSteading Institute is looking for getting flags in other countries. So that's kind of one of their big contributions to the SeaSteading movement, which is basically what we're doing. And SeaSteading is more doing it in international waters. We're starting off by doing this in local waters in the area that we're living, close to Panama, right on. Basically, we're at a marina, and the first development we're putting in the water is 1 kilometer away from the marina, so it's very close. And the advantage of doing that is that you are just a 5-minute boat ride. You can call a water taxi from the marina, and it'll come and pick you up and bring you back, or you can jump in your own boat if you have one tied to your sea pod. And then you have close and easy access to land, to restaurants, to services. And then you can drive to the big city if you want to go to the big city and have a night out or spend a couple days doing something. Or if you want to access international airports and travel, you can do that very easily. And then once we have a larger base, we'll set up another community in other locations around Panama. Panama has so many beautiful waterside communities that we could build these establishments in. And then we can also start going a little bit further out to sea. But I think the beginning point for the next several years is going to be always having a base close to land, because most people aren't adventurous enough to want to be 12, 13, 14 miles out to sea, or 100 miles out to sea, or even further. Some people are, and the technology that we're building gives that capability, but that's not something we're going to be pursuing in the immediate future, because there's this is a really good starting place, and it's really a necessary place to start, because we can't jump to living 100 miles from shore and not have go through the learning process, because we have to learn how to live comfortably at sea, and being able to access all the amenities of land is kind of an important stepping stone to getting there. So it will be a step-by-step process to getting there. And I think this is just one of the most incredible, most fascinating things that's happening on the planet right now. Maybe I'm a little bit biased, but I think the technological innovation that's going to come from this, I think, is just massive, because there's so much potential for, when you when you're going into new frontier, like if you're trying to go into space, there's a lot of technology you need to develop to be able to live in space and go to space. So there's a lot of technology advancement that comes from that. So I think by going to live on the water, we're going to have so much technological innovation that it's going to keep us very, very busy. And I think the amount of innovation that this will bring to people living on land will be significant. Like, we're looking for more efficient ways of using all the energy on the house, and more efficient ways of using the water on the house, so we can recycle and reuse the water as much as possible. So we don't have to waste any energy, because we're not going to have as much energy as we can't just plug into the power grid and have a nuclear power station nearby next door. That's something we want to get away from. We would like to have each sea pod be able to power itself, be able to produce all the power it needs to live comfortably. We want to be able to produce all the water we need to be able to live comfortably. We want to have the ability to grow our own food as well. And we may not be able to grow all of our food. I think we can probably grow solid 20%, maybe 30%, depending on if you're a vegetarian. You can probably grow a fairly large amount of our food. So I think that potential is there. We have lots of space in which to grow food. We actually have inside the pod, in the living structure, we have walls. We've experimented with some different areas that we can have wall gardens that grow on the wall, vertical gardens. We can also have the rotary gardens that I mentioned in the presentation earlier. We also have these huge tubes that are underwater, the outriggers, as we call them. They are on this prototype model that we have right in front of me here. We have 3 tubes that are 12 meters long. The production model is going to be 10 meters long. And so that will give us so 10 times 3, so that would give us 30 meters of growing space. So 30 meters in each meter is like a 1 meter diameter tube, circular. So that's a significant amount of space to grow food. So if you are a vegetarian, I think we can probably grow all the food that you need. And if you're not vegetarian, then it's not enough to have pastures where you can grow cows and have animals. But certainly, we're also researching algae and seaweed and some other things where we can maybe grow things outside on the spar, on the outriggers around the sea pod. So we could potentially grow protein sources in the area. So that could be very interesting. So yeah, there's a lot of potential in this. I think it's a fascinating adventure that we're on, and I think the future is going to have more and more people living on the water, and I'm curious to see what that would look like. I know there's a lot of different ideas of what a floating city would look like, or what a floating community would look like. This is our vision of something that's practical to start. We've seen over the years, many people that have so many different ideas of what a floating city could look like, or what a floating city would be, and they're usually very big, very grand, and they look amazing and really fascinating. But usually the cost of building them is massive, and we really need to start at a beginning point where we have like a baby step. And what we're building right now, I think, the biggest baby step that has been taken for actually making living on the sea a thing. So that's what we're doing. That's what we're all about. We're excited to have anyone that wants to participate and help us out, or partake in this grand experiment that we're embarking on. And we just want to work with people that are interested in working with us and seeing this vision come to life. You can get in touch with us on our website at oceanbuilders.com. You can participate in our contest. There's a contest tab on Discord. It's CE-salty-sensor-text. So we will be watching that space. So go ahead and there, and we will be checking that, and we'll leave a comment, leave your name, leave your information if you want to participate in the contest, and we will try to put a group together and put you into different groups to participate in making the contest, making a salty sensor. We have about 110 or so different projects that we would like to help sponsor, or help to foster, or encourage people to build, to make living on the sea a thing. We have most of those listed on the website in our wiki. So if you go to our wiki or to our web page, there's a little hamburger menu on the top left or top right of the screen on a desktop. If you're on a mobile phone, I think it may be on the top left. But there's a hamburger menu. Click that. Then there's a wiki, and if you click that, you'll be able to find our open source development projects. Check them out. See if there's something you're interested in participating in. We have a lot of lot of projects listed there, and we would love to have people participating and helping out, and developing some very fascinating, interesting technology. There's some cool water vehicles we can develop, water drones, underwater drones, surface level drones, aerial delivery drone services. Like when, like all these drone technologies that are coming available are really amazing, fascinating. But the problem with most drones is that being able to actually use them is a little bit tricky because there's so many rules and restrictions of flying drones over populated areas. But flying over the water, it's so much simpler. So we are probably the best use case scenario for showing the world with what drones can actually do, and I think that's really cool, really exciting because we can show the world what you can do with a drone. We can have a drone delivery service that is actually um, feasible, and you don't have to worry about flying over populated areas. And it's very practical because you can deliver product, like courier deliveries. You can have food deliveries. Potentially, we've talked about doing um, pickup for trash, for recycling, compost, and other things, which is really interesting to me. Um, we're probably going to use surface level water drones instead of aerial drones for things like trash and compost and recycling, just because if something falls out of the air, if the drone has an issue and um, all the things spill into the ocean, then that kind of makes a mess. So it probably makes a lot more sense to have that kind of stuff, to have heavy payloads going on an ocean, and water level surface kind of drone. And on our on our platform that we have, that is, let me just turn my camera out. You can see the sea pod here. The outer, right here, we have our outer spar, and you can see there's a little platform, gray platform on the top there, and there's a little white staircase there as well. So that is going to be a walkway, goes from the center spar, from the house, walks all the way out, and some stairs climbing up to a platform which we are making so we can land either delivery drones, or we're hoping, fingers crossed, to have what are they called? Vertical takeoff, VTOL, a vertical takeoff and landing drone, a manned drone that can actually fly out. Instead of taking a boat out to your floating home, you could take a drone. That would be super cool. We're really excited about that. We've been talking with eHang about coming out and doing that. So fingers crossed we'll have one here. So we're very excited about that. So I think I need to wrap up here. Thank you everyone for joining this talk. I hope you're interested in participating or communicating with us in some way. Get in touch on the website, OceanBuilders.com, or you can email me at grant@OceanBuilders.com, or check out our Salty Sensor contest here on Discord. Thank you very much. I guess I'm out of time, so I'll leave it, let the next presenter take over.
Well, welcome to our DEF CON session on maritime wargaming. In particular, we're going to look at the cyber operations surrounding ports. But first, what I thought I would do is talk a little bit about what we mean by gaming and what we mean by war, and also give you a little bit of my